This video covers the two topics of absolute value and imaginary numbers, and both of these topics are usually found in questions that are categorized by ACT as numbers and quantity, and we're going to go over each of these two topics in this video today. So when we begin with absolute value, usually you'll see absolute value denoted by the value, either constants or variables, inside these two bars. And absolute value refers to magnitude of the number. And when we're talking about magnitude, we're just talking about, in this case, the size of the number itself. We're not concerned with the sign of the number, the positive or the negative value. It's just the size of the number. So you can also think of absolute value as just the distance from zero on a number line. Let's look at this example. If the nearest fast food restaurant is 2 miles from your current location and it's located on the same street you are, then we're asked to sketch your position and the possible locations of the fast food restaurant. So give that a try, and then we'll show you what to look at here. So this might be a possible sketch. You know you're on the same street, you're in the middle with a smiley face. The fast food restaurant is 2 miles from you. It could be 2 miles to the east of you or 2 miles to the west of you if we're looking on a map east to west running left to right. We just know that it's 2 miles from your current location. So now let's think about that on a number line. We have the possible locations of the restaurant can be to our right or to our left. So we could write this as an expression, the absolute value of x equals to 2. If that's the case, what are the possible values of x in this case? Well, again, we're looking at the number line. We're right there at the 0 position. The x represents where, in our case, we were looking at the restaurant that's 2 miles. It could be 2 miles to the left or 2 miles to the right, and that would correspond in our case with a -2 or a +2. So when we have absolute value, we have two values. We have the positive value and the negative value. So when we're just looking at like the absolute value of a number, the absolute value of 10 is 10. The absolute value of -10 is 10. We're looking at the value of the number without regard to the sign. But what about when we have some kind of equation or expression in the absolute value bars? How many solutions do you have for this equation? The absolute value of 3x plus 1 is equal to 5, and we may be asked to solve for x. Well, we have to consider we have two possible solutions. We have one from the positive side and one from the negative side. So we have to look at the 3x plus 1 as both a positive value and a negative value. So we have to solve each of these two examples. On the left-hand side, we put the positive value. The right-hand side, in this case, we put the negative. And we'll run through and solve one value of x to be 4/3, and the other value of x when we solve to be -2. So you have two answers in this case when we have the absolute value. So that's what we need to remember about absolute value. And when you take the absolute value, though, of a number, a constant value, we're always going to get a positive value. But when we have to consider these equations, inside the absolute value could be positive or it could be negative. And that's why we have the two different cases here. Now let's look at imaginary numbers. This is a topic that you are introduced to in some of your earlier math classes, but maybe you don't do as much work on, but it's enough to get us started. And as you get into some of the upper level classes of Algebra 2, you're going to do a little bit more work. But here's what we need to focus on for the ACT. We want to remember that when we take the square root of a negative number, that becomes the imaginary number I. You may be thinking, but wait, my teacher always told me I can't take the square root of a negative number. In general, in our early math classes, we normally do say something like that. We don't want to take the square root of a -10, or we don't want to take the square root of a -4. We don't want a negative under the radical sign. But there is actually a mathematical skill that we'll use to handle square roots of negative, and that is imaginary numbers. And so this is what we want to look at. An imaginary number is a complex number. It's usually a real number multiplied by I. You may have a solution that comes up 2i plus or minus 2i, something like that. So real number multiplied by I, this imaginary number, and we have this property that we want to remember. This is usually what we'll see on the ACT, making use of this property here where I squared is equal to -1. Now there's a couple of things we can derive from this property, and that's what we're looking at in this graph below. We can talk about these different powers of I, and if you will remember that I equals the square root of -1. What we said the definition of imaginary number I was, it's the square root of a negative number. So let's go around this figure. We're going to go around in a clockwise order. If we begin at the top with I equals the square root of -1, let's square both sides. And when you square both sides, I becomes I squared. When you square the square root on the right-hand side, we lose the radical and we just have -1. That's our property we just said. I squared equals -1. Now, let's multiply both sides by I to give us I cubed. So when we multiply the right-hand side by I, it's just multiplying I times -1 gives us a -I. And then let's go around to get to the I fourth. We multiply by I again, we get I to the fourth on the left-hand side, and a -I times I is a -I squared. Using that we know that I squared equals -1 is the same as saying negative times -1 gives us +1. So these four things are really going to cover whatever we're going to do. If we have to multiply a set of expressions maybe together and FOIL out the two expressions, and when we multiply we come with these different values with these different powers of I, you can do some substitution with the values that we've got pointed out in the graphic here to simplify your result. And we'll look at some example problems in the questions that we have for imaginary numbers that deal with something just like this. But now let's take a look at an ACT type example. This particular example has to do with absolute value, so you can pause the video here and solve this expression. So this being an absolute value, we're going to work in pieces. We begin with what we're given, -4 times the absolute value of 4 minus 9. I always go with let's work inward, sort of like how we work with parentheses. First we want to take care of what's inside the absolute value, and 4 minus 9 is a -5. So now we want to take the absolute value of -5, which is just 5. So now we're down to just simple multiplication of -4 times 5, and that's going to give us a -20, and that should be answer choice B. Now what confuses people a lot on these type of questions is they see absolute value and think my answer has to be positive. You're sort of correct there. When you take the absolute value of a number, you are going to get a positive, but we have another calculation to do outside of that. We have to multiply what we get when we evaluate the absolute value. We multiply that by a -4, and that's what's going to give us the -20. So don't let that part get you. You are correct. The absolute value of a number is a positive, but then if you have to do any other calculations with that, that could end up giving you a negative, as it does in this case.